Today we're going to talk about Lesson 5-6, Probability Distributions. The big idea is the distribution of the probabilities of all possible outcomes from a situation can be displayed in tables and in graphs. In tables and in graphs. Okay? Moving along, it says, in a situation such as asking a question or flipping a coin, the possibilities are called outcomes. Okay? When you flip a coin, the outcomes of that could happen are heads or tails. No two outcomes can occur at the same time. You can't have a heads and a tails at the same time. A set of outcomes is an event. Okay, very important to know. Recall from your earlier courses that the probability of an event is a number from 0 to 1 that measures how likely it is the event will happen. So for instance, as Mr. Johnson's sitting at home, the likelihood that Mr. Turner is going to walk into my house is a 0. Okay? The likelihood that my son will walk into the room is a greater chance, which would be closer to 1. The sum of all probabilities of all possible outcomes must add to 1. If an outcome or an event is identified as X, then the symbol, probability of X, stands for the probability of the outcome or the event. So if you look here, my outcomes of heads to tails when flipping a coin, so the probability of flipping a heads, we know, is 1 out of 2. Okay? Probability of getting a tails when you flip a coin is also 1 out of 2. And as you can see, these two things added up is going to equal 1. So for instance, if you look over here at these circles, the probability of getting a green here would be 1, 2 greens, 2, 4 circles. So which is the same thing as 1/2. Probability of getting a yellow is 1 yellow to 4 circles. And the probability of getting a red is 1 out of 4 as well. 1/2 plus 1/4 plus 1/4 also equals 1. How are probabilities determined? There are 3 common ways in which people determine probabilities. You pick a probability close to the relative frequency with which the outcome or event has occurred in the past. You deduce a probability from assumptions about the situation, or you give a best guess. Probability distributions. Some situations have many outcomes. Probability distribution is a set of ordered pairs of the outcomes and their probabilities. For example, in many board games, 2 dice are thrown, and the sum of the numbers that appear is used to make a move. Since the outcome of the game depends on landing or not landing on a particular space, it is helpful to know that the probability of obtaining each sum. The following diagram is helpful because it shows 36 possible outcomes when 2 dice are thrown. So on the first dice, you have the opportunity to get a 1 through 6. On the second dice, you also have the opportunity of getting a 1 through 6. So if you look at this, as you roll 2 dice, the total number is 36. Okay? Is 36. So moving on. The probability of getting a 1. Okay? Can you just get a 1 when you add those 2 dice together? No, that can never happen. The lowest number we could get is a 2. So the probability of getting a 1 when you roll 2 dice is 0 out of 36. Okay? The probability of getting a 2, well, that only happens once, when the first dice is rolled a 1 and the second dice is rolled a 1. Otherwise, all these add up to something different. So it's 1 out of 36. How about the probability of getting a 3? Where can we get a 3 at? Well, here's a 3. Here's a 3. That's a 4. That's a 5. That's a 4. That's a 5. That's a 4. Okay? So how many times could I get a 3? Twice out of 36. How about the probability of getting a 9? Okay? The probability of getting a 9. Well, here's a 4 and a 5. So I'll mark that. 5 and a 5, or a 5 and a 4. But what about our 6 and 3s? So I could get a 3 and a 6, or I could get a 6 and a 3, right? Notice how these kind of line up in a row as they're written out. So yeah, that's 4 times out of 36. What's the probability of getting a 5? Okay, well, 1 and 4, 3 and 2, 3 and 2, and 4 and 1. Okay, there's also 4 of those. 4 out of 36. Oh, yeah. Okay. How about the probability of getting a 6? Okay. Probability of getting a 6. Well, you got 3 and 3, 2 and 4, 1 and 5, and 2 and 4, and 1 and 5. 1, 2, 3, 4, 5. So that's 5 out of 36. Pretty simple, eh? Let's move on. We call a situation unbiased or fair if each outcome has the same probability. If the dice are fair, then each of the 36 outcomes has a probability of 1/36. So each one of those could equally have a chance of happening. Okay? That's unbiased or fair. Okay? The dice aren't loaded. So if you look at this, they made a chart. Probability of getting a 2 was 1/36, which comes out to that. Okay? So as you're rolling 2 dice, your best probability of something happening is getting a sum of 6, 7, and 8. Okay? So that would be your best probability of getting it. So if you're betting on something when rolling 2 dice, the sum of 2 dice, your best probability is a 6, 7, or an 8. Moving along. Probability of an event with equally likely outcomes. If a situation has a total of n equally likely outcomes and E is an event, then the probability of E is the number of outcomes in E divided by the number of chances. Okay? So, the probability distribution from relative frequencies. Your blood and the blood of all humans is one of these 8 types. O, A, B, or AB, and either positive or negative. So there's O positive, O negative, A positive, A negative, so on and so forth. For each of these, depending on the existence of this antigen. Overall, in the United States, the approximate percents of people with these types are shown in the table on page 283. Note that the percents do not add to 100% due to rounding. Okay? So example 1, here's my percentage and so forth. Example 1 says, what is the probability that a person in the United States has type O blood? Okay? What is the probability that a person in the United States has type O blood? Okay? Well, where's type O? Type O is right here. Okay? So the probability of that is 38%, 0.4% plus 7.7%, which equals, okay, 38 plus 7 is 45 plus 1.1. So 45 plus 1.1 is 46.1%. Okay, all we had to do was add those together. B says, what is the probability that a person with type O blood is O negative? Okay, so to do this, what we have to do is we know the percentage of people that have type O blood, right? So that's going to go to the bottom. So I'm going to put B here. So 46.1% of the people are going to have type O blood. And then the percentage of O negative is 7.7. Okay, so only 7.7 of type O can be O negative. Okay, so on your calculator, what you can do is take 0.077 divided by 0.461. And that's going to give you 0.077 divided by 0.461 equals approximately 16.7%. Okay? Moving along. The probability calculated in example 1b is called a conditional probability. It is the probability that a person has type O negative blood given the condition that they already known to be type O. You can write this as the probability of O given you know that they O negative given you know they're O, which is 16.7% as we said earlier. So in general, the conditional probability of event B given event A is the probability of B given A is the probability of A and B divided by the probability of A. Okay? That is, it is the probability that both events occur divided by the probability of the first event. Moving along. Complementary events. If the probability of a tornado occurring on a weekend is 2/7, then the probability of a tornado occurring on a weekday is 5/7, because there are 5 weekdays in a week. The events occurring on a weekend and occurring on a weekday are called complements of each other. 2 events are complements if they have no elements in common, and together they contain all possible outcomes. So 2/7 on the weekend, 5/7 on the week, fills up the whole week. Okay? The sum of the probability of an event and the probability of its complement is 1. So if you know one, you can easily find the other. Okay? Same goes for relative frequencies. Thus, the probability of relative frequency of the complement of an event is found by subtracting the probability or relative frequency of the original event from 1. So, looking at this problem, a weather forecaster reports that the probability of rain tomorrow is 80%. So, the probability of rain equals 80%. That means the probability, what is the probability that it's not going to rain tomorrow? The probability of no rain is equal to 100% minus 80%, which is equal to 20%. Because if there's an 80% chance it's going to rain, then there's a 20% chance that it's not. Okay? Moving along. Odds. Probabilities and complements of probabilities are used to compute odds. Odds are stated and used in different ways that are not always the same. One meaning is that the odds of an event occurring is the ratio of the probability that the event will occur to the probability the event will not occur. Probability that the event will occur to the probability that the event will not occur. So, odds of E occurring equals the probability of E divided by the probability of its complement is equal to the probability of E divided by the probability, 1 minus the probability of E. So for an example, If you think the odds of being selected for a particular honor are 2 to 1, then you mean that you will be selected 2 out of 3 times. And that probability of the event is 2/3. This shows how to calculate a probability from odds. If the odds for the event are m to n, then the probability for the event is m divided by m plus n. And the probability the event will not occur is n divided by m plus n. So let's move on. Cameron is managing a large product at work that is being scheduled. He estimates that there is a 1/4 chance it will be completed on time. What are the odds it will be done on time? Okay, so what we know is there is 1/4 of a chance for it to be done. So 1 is the chance of being done. Okay, the complement to this is 4 minus 1, because we know there's 1 chance of getting it right. So 4 minus 1, sorry, I wrote 3 because that's what I was thinking. Okay, 4 minus 1 is 3. So the odds of this getting done on time is 1 to 3, which is about 33%. Okay, so if you notice what Mr. Johnson did, you take this top number to this number minus the numerator to get your odds. That's all I have for you today. Please enjoy. We'll see you tomorrow.